So now we're going to talk about Gay-Lussac's law. This law gives us the relationship between pressure and temperature if volume and amount are held constant. Before trying a problem, let's think about this intuitively. Suppose I increase the temperature inside this container. This means that the gas molecules will move faster and they will impact the container walls more often. Now let's also assume that the container has rigid walls and thus a constant volume. Well, what will happen is that the gas pressure inside the container will increase since the molecules will impact the walls much more often. So if the temperature of a container is increased, then the pressure increases. In the last video, we learned that this is a direct mathematical relationship. As one value goes up, the other one also goes up. Since this is a direct relationship, we can come up with an equation that is similar to Charles's law. And this equation is P1 over T1 equals P2 over T2. This equation will be very useful to you when solving Lussac's law problems. But remember, you want to make sure to convert any Celsius temperature to Kelvin before using it in your calculation. Here is an example. A gas is found to exert 735 millimeters of mercury at 25 degrees Celsius. What would be the required temperature in Celsius to change the pressure to standard pressure? So before I solve this problem, I encourage you to pause this video and try it on your own using our Lussac's law equation. P1 over T1 equals P2 over T2. Alright, I'm assuming that you attempted it. So I'm going to start putting our given values into this equation. P1 is 735 millimeters of mercury divided by T1. And once again, you might be tempted to just use a Celsius temperature, but you have to convert to Kelvin temperature. So to convert from Celsius to Kelvin, we add 273. 25 plus 273 equals 298 Kelvin. You don't want to get too caught up with significant figures in these intermediate steps, so we'll just put 298 Kelvin. And that equals P2, which is the pressure of the gas at which we are trying to find the temperature. And the problem tells us standard pressure, which in millimeters of mercury is just 760. So 760 millimeters of mercury divided by, we're looking for the temperature, so we can leave that as T2. So to continue solving this, we can cross multiply. So 735 millimeters of mercury times T2 equals 760 millimeters of mercury times 298 Kelvin. Now, to isolate our final temperature, we need to divide both sides by 735 millimeters of mercury. So divide by 735 millimeters of mercury on this side, and divided 735 millimeters of mercury on this side. And this will allow us to completely cancel out the value on this side and cancel out the units on this side. So what we have left is T2 equals 760 times 298, all divided by 735, and we're retaining our unit of Kelvin, and that's going to give us a temperature of 308.1 Kelvin. And we're not done yet. The original problem asked us for our answer in Celsius, so we need to subtract 273 from our result. Minus 273, and that gives us a final answer of 35.1 degrees Celsius. Hopefully you got this. It should make sense to you. Since the pressure slightly increased, the temperature slightly increased. Thank you for watching.